Okay, so all the sodium rushes in, right, when you depolarize a segment of the membrane, right, to -55 to the threshold, and then, those voltage-gated sodium channels open, the sodium comes in, right? And when the sodium comes in, where do you think it's going to go? So if you look at, the overhead that's titled AP, or action potential propagation, right? This shows you a little segment of the membrane, near the axon hillock, in fact, that's been sort of expanded out. And you can see the, phospholipid bilayer, the impermeable phospholipid bilayer. You can see an open, right, an ungated voltage-gated sodium channel with a lot of sodium rushing through, right? And all that sodium is collecting there, in the membrane, on the inside of the cell by the membrane. And it's changed the resting potential, from -65. It's changed the membrane polarization to +20 briefly on the inside. So the question that's asked here is, which way will this sodium current now move? And also the question is, why will it move? Look a little bit further down the membrane, right? There you see a gated, voltage-gated sodium channel, one that's not yet open and not yet permitting the entry of sodium into the cell, right? And that's why the reason is because it's at -65. It's at the resting potential, just a little bit further down the axon, right? So it's voltage gated. It only opens at the threshold of -55. A little bit further down, it's still at the resting potential, so it's in its closed conformation, right? Well, you now have a huge amount of sodium right over here, a little bit to the left, right? And it's positively charged in this area. And a little bit to the right, you've got a negatively charged, -65, and you've got very little sodium. Well, what forces are going to drive, your sodium, from the left to the right, down that axon, and what will be the consequence of moving a lot of positively charged sodium ions into an area that was formerly at the resting potential with, voltage-gated sodium channels and potassium channels in the closed conformation.